In this video, let's understand the benefits of learning linear equations and especially linear equations in two variables. We already know the importance of equations in algebra. We know that there are different types of equations, and linear equations is one such type of equations which we will study in detail here. Now, let's see what are the different types of linear equations. Linear equations are equations of degree 1. So, for example, we can see an equation 5x minus 4 is equal to 0. Here we can see that degree of this equation is 1. We can see one more equation 3x minus 2y minus 2 is equal to 0. In this equation also degree is 1. So this is also linear. But can you tell the difference between the two equations? Well, in the second equation we can see additional variable of y. In real life, we will have many situations where we will use two or more variables in equations. So it is necessary to study linear equations in two variables. Let's take an example. Let's find the perimeters of squares. We know that perimeter of a square is found by the formula P is equal to 4a, where a is the side of the square. P is equal to 4a is a linear equation, and in absence of this linear equation, it would have been very difficult to find the perimeters of the square had the squares been very small or very large. We are able to form this linear equation P is equal to 4a from the knowledge that perimeter P is directly proportional to the side of the square A. That means if A increases, P also increases. Similar situations we have in real life also. We know that force required to move an object is directly proportional to its mass, and we also know that circumference of a circle is directly proportional to the radius of the circle. With the help of linear equations, we can form the equations from direct proportionality. That means force is directly proportional to mass. From this we can form an equation force is equal to mg, where g is a constant, and from c is directly proportional to radius, we can form an equation circumference c is equal to 2 pi r. So with the help of this equation, we can actually calculate the force required and circumference of the circle. And if we look at this equation, force and mass here have a linear relationship. Similarly, here also, circumference and radius also have a linear relationship. Let's discuss how linearity helps us. Well, if we look at the spring balance here, we know when the mass of the object suspended from the spring balance is increased more and more, the spring of the spring balance gets stretched more and more. This spring balance can measure weight up to only a certain limit. Let's say the limit for this is 50 kg, and what will happen if we suspend a weight of 100 kg on this spring balance? This is where the idea of linearity helps us. In the last spring here, we have put the weight beyond the limit of this spring. And on the graph of weight versus extension, we can see this is the point where weight more than the limit of the spring has been suspended. When this is done, that means more than the limit the weight is suspended, then the behavior of the spring is not as expected and it becomes non-linear. And non-linear behavior is shown by this portion of the graph. Had the behavior been linear, then the graph would have been in this direction. This knowledge helps us in selecting the weight which we should put on the spring balance so that the weight can be measured accurately. Let's summarize what are the important things we have learnt in this video. It is important to study equation as it gives us opportunity to equate two quantities and then solve problem. Linear equations help us understand the linearity of relationship between two variables. Linear equations are formulas that connect these variables. Analyzing real-life situations need a deeper study of linear equations, and this helps us predicting the behavior of one variable depending on the other.